Hello, this is Mrs. Cole, and we are going to do our lesson today on similar shapes. Similar shapes are going to be a nice application of what we've been learning about with proportions. But before we can talk about proportions and similar shapes, we have to get some basic background. The first thing to do is talk about what the word similar means. Now, similar can have two different meanings. It has a common meaning that you use in common language when you're talking to your friends or whenever, and it just means that things have some matching features. Some of them are matching, maybe not all of them. Parts of these things might be proportionate. Maybe it's better if they are, but they might not be. And it's very subjective, because all you have to do is say one thing is like another thing. In math, it is far more precise, and you can actually calculate it. So each feature has to be specifically matched and identified. And each part is directly proportionate. There is an equation we can use that is the same for the entire shape, and it'll work. And it meets this very precise description. The corresponding lengths are proportionate by the same scale, and all corresponding angles are congruent. Now what this means in regular language, it means the parts that match, those are the corresponding parts. So the lengths, the sides that match, they are proportionate. It means that every single one of the small one multiplied by the same number will get you to the bigger one. That means you use the same number to get to the biggest one. And when it says the corresponding angles are congruent, it just means that if you took your protractor and measured all the angles, the ones that match up would have the same measure. We also need to talk about some symbols that we're going to see. The first ones, the angle and the triangle, are pretty easy to guess. Parallel and perpendicular should be pretty familiar from previous years. Parallel are lines that are next to each other, they travel and they never touch. Perpendicular means these are two lines that meet at a right angle. And a right angle in a drawing, especially if you have polygons, the right angles are normally identified with this box in the corner. This one might be new. It's talking about a line segment. So if I say this line, AB, it means just a line that has the points A and B on it. One of the important things we're going to be talking about today is this mark for congruence. So if you have two sides that are congruent, they have the same number of slashes through them. So these two sides with only one slash, they're congruent. And these two sides with two slashes, they are congruent. Angles are congruent if they have the same number of arcs. So this angle only has one arc, but these angles both have two arcs. So these angles are congruent. They'll have the same measure with a protractor. When we talk about the measure of an angle and we need to write it down, we say measure of angle ABC, which if you look up here, it means the angle that goes from A to B to C has this measure. So you have this little M out front, measure of angle ABC, and this letter in the middle is actually the one that sits on the vertex. It's the one at the point. A and C are at endpoints. So we have these two lines and they meet at B. Now that we have all of these symbols, we can write almost an entire sentence with just geometry symbols. We can say the measure of angle ABC is congruent to the measure of angle BCA, so triangle ABC is isosceles. And I want you to notice a couple things. This symbol means congruent. It means they have the same measure. This symbol means triangle, and then we name it. So we have triangle ABC. Triangles and polygons are named in a clockwise fashion. So we go A, B, C. It would be wrong to say triangle ACB. Well, not wrong, just not what we normally do. Okay, so that way we know that we're going in this clockwise fashion and they match up. Now we can use this to start talking about proportions. And we can actually use it to talk about if two things are similar. A test to see if two triangles are similar would just be that they have two corresponding angles with equal measures. So first we have to talk about which parts are corresponding, and we have to write similarity statements. We can talk about angle CAB being congruent to to angle FDE. So we write angle CAB is congruent to angle FDE. And we know that because we have these arcs that only have one arc here. So there's one more. Pause the video and find the other one and write it down. The other one would be angle ABC is congruent to angle DEF. So now we know that these two triangles are similar because two of their corresponding angles have the same measure, which therefore means the third one has to have the same measure because you can only have 180 degrees in a triangle. So now we can solve a proportion and find out what this missing side is. When I set up my proportion, I like to have the corresponding sides in the same ratio, and then I put one triangle in the numerator and the other triangle in the denominator. So I would put 3 corresponds to 9, and 7 corresponds to x. I have 3 corresponding to 9, and 7 to x. And this way I have my one triangle in the numerator, and my second triangle in the denominator. And now I solve my proportion. I just cross multiply and divide. So I have 9 times 7 divided by 3. And my answer is going to be 21. So I can now say that this side has a length of 21. Before I stop, I need to make sure I clarify. Triangle AC similar to triangle DEF. These two wavy lines mean similar. Here's some examples for you to try. The first thing to do, remember, is to find your corresponding parts. So we have DAB corresponds to ZWX, and we have BCD corresponding to XYZ. My first one I'm going to find is X. So I'm going to compare 10 to 4 and X to 5. 10 to 4 and X to 5. Cross multiply and divide, and I get 10 times 5 divided by 4 equals 12.5. Why don't you, on your paper right now, try to find Y and Z from this polygon. The first proportion I would set up to find Y would be comparing, this one's set up slightly differently. So I put the same polygon in the same ratio, and then I made sure that 10 corresponds to 4 and 8 corresponds to Y. Cross multiply and divide, and we get Y equals 3.2. Try the last one for Z. Here we go. 10 over 15, same polygon, and then 4 to Z. So 10 corresponds to 4, 15 corresponds to Z. Cross multiply and divide, and you get 6. Now we can do a word problem. Word problems are going to have 3 steps. Okay, first you have to read it. Tree casts a shadow 7.5 feet long at the same time that a woman 5 feet tall casts a shadow 3 feet long. How tall is the tree? It's very important that they do this at the same time so that the sun hits them at the same angle. Well, the first thing we need to do is to draw a picture. So here's my tree, and there's its shadow, because the shadow is mentioned in here and it has a length. It's kind of important. And then I need to draw my lady. And now I need to find similar polygons. I don't see any polygons here. So the last thing you need to do is you need to figure out which polygon is going to be here. One of the most common ones you will see is a triangle. So I'm going to draw a line from the top of the tree to the end of the shadow, and I'm going to make a triangle. One of the other important things is I strategically position my person here so they're on the same triangle. I could draw them separately, but this is just easier. And now I need to solve a proportion. So I need to figure out which numbers I'm going to use. I'm going to use, she's 5 feet tall, and her shadow is 3 feet long. I also know that the tree's shadow is 7.5 feet long. What I don't know is how tall the tree is, so I put a variable there. I'm going to say T, because I'm sick of using X, and T stands for tree. So now I set up my proportion. 5 corresponds to T, that's the heights, and then the length of the shadows, this is the ladies, this is the trees, so we have 3 to 7.5. And now when I cross multiply and divide, I'm going to get 12.5 feet. Don't forget your units. Alright, have a nice day.